Hey everyone, welcome back. Today we're going to talk about the areas of composite figures. First of all, you need to know what a composite figure is. This is a figure that can be separated into regions that are basic figures, such as triangles, rectangles, trapezoids, and circles. Other basic figures that we've learned about are rhombi, kites, etc. In order to find the area of these composite figures, you'll separate them into these basic figures, find the area of each basic figure, and add them all together. So we're using the area addition postulate, which you can find the definition of that on page 1 of your notes. Let's try an example together. So let me show you this. It says the dimensions of a putting green at a mini golf course are shown. How many square feet of carpet are needed to cover this green? So the first thing we want to do here is split up this composite figure into smaller basic regions. So I will look at this region X. This is a half of a circle, so it's a sector with a central angle of 180 degrees. I'll look at this section Y, this is a triangle, and this section Z. So in order to find the equation, I know that the area of this composite figure is going to be the area of X plus the area of Y plus the area of Z. Now, I'll have to go through and add in the formula for each of these separate figures. So, I have two steps in my equation this time. So, for the area of X, X is a semicircle. This is represented by a sector. The area of a sector is X over 360 times pi r squared. Next, for the area of Y, Y is a triangle, so I can substitute in 1/2 base times height. Finally, for the area of Z, I know that Z is a rectangle because I know this would make a right angle. So I know that the formula is length times width, or base times height. Now I can move on to S for substitution. For the first shape, X represents the central angle measure. In this case, I know that the fraction of the circle is a half, so I can just go ahead and use a half, or you could plug in 180 over 360. Note that's the same as 1/2. The radius of this circle I see is given to me in the figure 4 feet. So I'll plug in 4 for the radius. Next, for the triangle, the base of the triangle, I can use 4. The height is not given to me though. I know that this is a right angle, so I know that the height would have to be the length of this segment right here. I know that it's a right triangle, but I'm missing one of the sides. In order to find the missing side of a right triangle, I can use Pythagorean theorem. So I'll just give this a variable a. I know a squared plus 4 squared has to be equal to 5.7 squared. You guys should know how to solve that for a, and you should get square root of 16.49. And I could plug that in to get 4.06, but I'm actually just going to leave it like that for now so that I don't get rounding error. I want to plug in everything at once to my calculator at the end. So I'm just going to leave it like that for now. Finally, for the rectangle, I see that the base, I could use 4 feet, where the height will be 7 feet. Those are perpendicular to each other, so I know I can use this for the base and the height. So I have 4 times 7. All right, the next S stands for solve. So I'll go through and plug each of these in. If you want to do them one at a time, the area of the semicircle, you should get about 25.13. The area of the triangle, you should get about 8.12. And the area of the rectangle is exactly 28. Add them all together, and you should get 61.25. So your answer with the units, the area is 61.25 feet squared. So the amount of carpet that they need to cover the putting green is 61.25 feet squared of carpet. All right, I want you to try the 2 practice problems that I have listed for you below. Here are the correct answers. For 4A, I used a rectangle and a trapezoid. You could have also used a rectangle, another rectangle, and a triangle if you wanted, but I saw that I could use a rectangle and a trapezoid. As long as you get the right answer, 155.5, you're fine however you did it. For B, I used a triangle to figure out the height of my trapezoid. So I was using a trapezoid as shape X and a semicircle is shape Y. Add up the 2 areas and you should get 374.5 centimeters squared. All right, next let's do this example, example 5. Sometimes you won't necessarily want to do it by adding areas. That could be more complicated. Sometimes you might want to do it by subtracting areas. So if I see one like this where it looks like this triangle was cut out of a rectangle, I might choose to do this with subtraction. So I'm going to call figure X the rectangle and figure Y is this triangle right here that was cut out of the rectangle. So my equation for the area, I want to do the area of the rectangle, so the area of X, I can just write, minus the area of Y, since Y was cut out. For the area of the rectangle, I need to find the base times the height. For the area of the triangle, the formula is 1/2 base times height. Now I can use substitution. For the rectangle, the base and the height have to be perpendicular. I see 5 meters can represent the base, while 6 meters can represent the height, since those are perpendicular. Doesn't really matter what order you plug them in. Next, for the triangle though, I don't really know if this is a right angle or not. So what I can do, I'm going to actually redraw this so that it looks a little bit easier to draw on for me. And I'm going to draw this. This is called the altitude. Remember, we can represent the altitude with A. Now, I know that this length is 4 and 4. I know that this whole base has to be 6. Since this is an isosceles triangle, I know that these 2 angles would have to be the same on the base. That means that each of these triangles, the smaller triangles, the triangle here on the left and the triangle here on the right, have to be congruent to each other by side angle side. So, what that means is that each of these would have to be 3. So I'm going to look at this little triangle right here. Be careful. Don't get tricked and say that this is a 3, 4, 5 triangle, because remember, 5 would have to be the hypotenuse. So instead, in order to figure out the length of A, I'm going to use Pythagorean theorem. I know that A squared plus 3 squared would have to equal 4 squared. So that gives me A is the square root of 4 squared minus 3 squared, or the square root of 7. So A is the square root of 7. So that means the base, I can use 6 for the base. The height, or the altitude, is the square root of 7. So I'll plug that in for height. Now I can go ahead and solve. 6 times 5 is 30. 1/2 of 6 is 3. There's my exact answer. If I want an approximate answer, I can plug this into my calculator. 30 minus 3 radical 7 gives me 22.06. It told me to round to the nearest tenth. Make sure you're rounding correctly. So the area is about 22.1 meters squared. On the next page, you will see 2 practice problems. I think it's actually on the same page for you. Here are the correct answers for those 2 practice problems. For part A, I used a trapezoid minus a triangle. For part B, I used a parallelogram minus a rhombus. All right, here's what I want you to reflect on tonight. It says, consider the sequence of area diagrams shown. What algebraic theorem do the diagrams prove? Explain your reasoning. What I want you to do for this is maybe think about the area. What's the area of this shape? The shaded figure. How can you find or represent the area of that shaded figure? Now, how could you represent the area of this rectangle? All right, that's all I have for you today. Tomorrow we're going to talk about areas of similar figures. So I look forward to seeing you then. Bye.